us go further. Last time we have seen VCM, vertical circular motion, by using a string. Now next point of this chapter, the concept of again VCM, vertical circular motion, by using a rod. So in place of string, if we imagine the rod, and that rod is rotated in vertical circle, what is called as vertical circular motion by a rod. So consider a single particle or a body of mass m attached to one end of the rod, and suppose this rod is rotated in vertical circle. What we get is vertical circular motion. Now in this typical case, in place of string, a rod is there, and therefore this rod cannot become loose or slack. Even though velocity changes continuously, this rod remains as it is without change in form. In other words, I can say that even though velocity at this typical point, highest point, is minimum, even though there is a possibility of VCM, we are saying that when body moves in downward direction, then at lowest point, because of gravitational force, velocity is maximum, and as we go away from Earth's surface, moving upward direction, because of gravitational force, this velocity decreases. So I can say that at point A, topmost point, highest point, velocity is minimum, and at bottom point, velocity is minimum. Let us find out velocity for at point A. Last time we have seen, in previous standard we have seen the concept of projectile. If we throw a body in upward direction, then making some angle with horizontal, then what is called as a projectile. So this body moves in upward direction at highest point. Momentarily the body velocity becomes zero. So body does not fall to its at this typical position in downward direction. It continues to move in this direction. Why? Because of the property of inertia. Every body tries to remain in its own state of motion unless and until it is acted by external unbalanced force. Same thing happens here when body is moving, and suppose at this typical point velocity is zero, just like this. Then the body does not fall, but it continues to move in forward direction because of tendency of the body, that is inertia of the body. So I can say that even though velocity at this typical point is zero, there is a possibility of vertical circular motion. So I can say that at topmost point, minimum velocity by using rod can become zero. So we get at top point, minimum velocity is zero. That means V1 is zero. Let us see now velocity at bottom point B in VCM by rod. Again, see diagram. Here rod is there. Point A, upper point, just now we have seen that minimum velocity with which this VCM is possible at topmost point V1 is equal to 0. We have seen this part. Now our aim is to find out velocity at bottom point, lowest point of VCM by using rod. Again, to find out velocity at bottom point, again we use the concept of law of conservation of energy. That means total energy at any point of this circular motion, vertical circular motion, is constant, unchanged. There is no loss and no gain of energy in this typical motion. So two points are considered, point B, lowest point, and upper point, point A. So total energy at point B is equal to total energy at point A. This energy is nothing but a combination of two things, kinetic energy and potential energy. Kinetic energy and potential energy. For kinetic energy, the standard formula is 1/2 mv square. So here for point B, we assume that V2 is the velocity. And mgh, standard formula for potential energy. In place of h, we consider h2 with respect to point B. Similarly, on the other side, 1/2 mv1 square plus mgh1 with respect to point A. So for point B, h2 is equal to 0. Why? Because this is the lowest point in VCM, and we assume that for our simplicity, h is equal to 0, starting point. With respect to this, we are measuring height. So we get h is equal to 0. That means h2 is equal to 0 for point B. Then h1 means this typical distance with respect to point A, upper point. The distance of point A with respect to a reference point with respect to lowest point is radius plus radius. That means 2r. So we get h1 is equal to 2r. And just now we have seen that the velocity, minimum velocity with which this VCM is possible for using the rod, its V1 is equal to 0. So we get V1 is equal to 0. Putting all this value in this equation, we get 1 half m V2 square plus mg in a bracket 0 is equal to 1 half m V1 square. What is V1? 0 square plus mg into h1. That means 2r. So we get 0 into anything is 0. 0 into this we get 0. So we get 1 half mv2 square plus 0 is equal to 0 plus twice mgr. So we get 1 half mv2 square is equal to twice mgr. This common term m get cancelled. So we get v2 square is equal to 4gr. Our aim is to find out expression for velocity. That means v2. So take roots of both sides. So we get perfect square of under root v2 square is equal to under root 4gr. Perfect square will be outside. So v2 is equal to 2 under root gr. This is our required answer. That means velocity at the bottom point. Now let us see.
Yes.
Now we see third point. That means middle point, horizontal point. So point C is the middle point, or we can say that horizontal point. Point A upper point, point B lower point, and point C is middle point. Now our aim is to find out velocity expression at point C. That means middle point. Again same concept just like previous article. We require law of conservation of energy. And so energy at point B is equal to energy at point C. So total energy at point B is equal to total energy at point C. So again kinetic energy plus potential energy combination at point B is equal to kinetic energy plus potential energy at point C. We call this velocity at point B as V2. We call velocity at point C as V3. We call height at point B H2. We call height H at point C is H3. So we get at point B H2 is equal to 0, reference point, starting point. Then H3, this typical distance of C with respect to reference line, it's H3, nothing but R. So we get H3 is equal to R, and we obtain expression for V2 just now previous article. V2 is equal to 2 under root GR. Putting these values in this equation, upper equation, above equation, we get 1 half m V2 square plus mg into 0 is equal to 1 half m V3 square plus mg into r. Simple mathematics is there. So we get 1 half m. In place of V2, we write this value twice under root gr square plus 0 into this 0 is equal to 1 half m V3 square plus mgr. So we get 4grm upon 2 is equal to 1 half m V3 square plus mgr. Now this 2 and this 4 get cancelled. We get 2. 2grm is equal to 1 half m V3 square plus mgr. Common terms, m left hand side common term is m, right hand side common term is m, cancel. So we get twice gr is equal to 1 half V3 square plus gr. So we get twice gr minus gr, this term on this side which becomes negative is equal to 1 half V3 square. So we get gr is equal to V3 square upon 2. We want to find out V3 square. So V3 square on one side, after this on this side, V3 square is equal to twice gr. We want to find out only V3. So roots of both sides. So we get under root V3 square is equal to under root twice gr. So we get V3 is equal to under root twice gr. This is our required expression. That means velocity at middle point. So we have seen 3 points: upper point, middle point, and horizontal point. In examination question can be asked, obtain expression for upper point, lower point, and middle point in case of a VCM by using string or by using rod. Out of these two, understand properly the word, then find out the answers.